Thank you, and welcome to the WEBRTC Working Group meeting on July 15th, 2025. Next slide. This group is spanned by the W3C IPR policy. Only people and companies listed on this link are allowed to make substantive contributions to the WEBRTC specs. Next slide. This is the July meeting, and we have, I'm going to go back, we have some updates on future meetings. There's no meeting in August, and dates for September and October are yet to be announced. And TPAC this year is in November, where you'll find WEBRTC on Tuesday the 11th and Thursday the 13th. I believe there's also a joint meeting with media later that Thursday. Next slide. Here's our meeting info. The next slide. Please abide by the code of conduct. And we're using the Google Meet queue. Please get on the queue if you wish to speak. And next slide. We're going a little fast here. We can skip this one. Document status. Posting a W3C repo does not imply adoption. Look for working draft and call for consensus on the mailing list. So that brings us to issues for today. We have header extensions from Harald, RTP transport update from Peter, data channel transfer from myself, and the grab bag of issues. So we hopefully have a light schedule today, but we'll try to follow the time controls as well still. So with that, over to Harald.
Thank you. So I filed an issue saying, let's move this. RTP header extension control has been deployed in Chrome for a while. We have an implementation, we have a spec, we have positive signals from other vendors. I think it satisfies all the formal requirements for being included as a proposed amendment in the main spec. But of course, moving stuff around just for that is make work. There is another reason. Because when dealing with some header extension work, I discovered that the spec is actually quite unclear about what the header extension, when you do get parameters, you get a list of header extensions that are on senders and receivers. And the language is actually quite unclear about how they're populated and when they're populated. And so I found that easiest thing to do is to say that that these are populated based on the content of negotiated header extensions from the control spec. But negotiated header extensions, of course, can't be referenced from the main spec to the control spec. So moving the extensions control spec from the extensions to the main spec seems like the natural thing to do. And so I just wanted to see, should I prepare that CL or should I do something else? Opinions from the working group. Jan Ivar?
Yeah, so I think I don't see any big problem with that. I think on the actual API, I think I still had some concerns about if we could move away from dictionaries to interfaces, but I'm happy to keep arguing. You know, nothing has happened here for a long time, so I don't see a problem with moving. I can still make those, try to make those improvements in the main spec. So I'm happy with that. Also, before I forget, I did mess up in the intro. We didn't get a scribe and wondered if we could get a scribe. Sorry about that.
I am scribing.
Thank you, Dom.
Thank you.
But can you remind me and I think the extension spec, what we originally said, I thought did we not want two implementations, or was it one implementation and one commitment.
The latter.
Okay, great. No objection from me.
Okay, I will prepare a CL to remove the stuff. Not fast, but it will be done. Thank you. And we are ahead of schedule. Peter, over to you.
All right. Can you hear me?
Janiva raised his hand.
Yeah, sorry, I just reminded that you were planning some cleanup with codecs and directions and stuff, and will this help with that as well?
It actually came up through a different path of things I'm doing, but yeah, some of the same things apply, but not right now.
Okay, all right, thanks. Sorry, Peter, go ahead.
Okay. Can you hear me?
Yes,
Is there background noise or not?
some waves and stuff, but I think it's fine.
Okay. So I want to talk about RTP transport. First, a reminder of the goals. This is a summary or a shorter version of what's on the repository on GitHub. Mainly customizing things, payloads, packetization, metadata, jitter buffers, congestion control, and potentially use case affording. But we kind of have a goal that's not written there, which is that we would like it if we can put an API in so that any future advanced or niche use case can be served so that nobody has to come back and ask for more stuff again. It's kind of like the final API. You can do whatever you want because it's so low level. That's a goal, but yeah, if we only get 90% there, it's still pretty good. All right, next slide. So far, we have done this approach called piecemeal, which is to have an incremental API on top of Pure Connection. So someone who's using Pure Connection can use a piecemeal or a part of what we're adding. And we made some pretty good progress on that in our specs and in our docs, lots of good discussions, and you can go see the status of that at GitHub. But we got to the point where like, okay, let's implement this thing. And it turns out that the implementation is pretty complex because Pure Connection is complex. And we're trying to make it even more complex. So next slide. We kind of went back to the drawing board a little bit and thought, okay, what if we took a different approach, you know, kind of back up. If there's a dead end because the implementation is too difficult, should we kind of back up and go down a different path? And so we thought of this thing. I'm just calling it simple RTC transport for now. You know, we can bike shed whatever name we want. So imagine something that's like peer connection in the sense that it's real time, it's peer-to-peer, it's encrypted, it's got consent checks, all those properties we need. But unlike peer connection, which handles all the packets for you, this is an API just for sending and receiving packet. It's packet-based. So the developer can control the packets, a bit like with the data channel where you can control messages, but like that's the entire API, just packets in and out. And the developer can also control the pacing or bandwidth estimate with some circuit breaker. So same goals as RTP transport, except instead of extending peer connection and doing the piecemeal thing, we say, okay, we're just going to provide this low-level thing that's packet-oriented. And importantly, this would mean that there's no SDP guardrails. There's no interactions with existing peer connections where all the complexity of implementing lies. So the implementation would be a lot more simple. The API would be a lot more simple, but it's no longer piecemeal. Now it's like an alternative path. Is everyone with me so far? Any questions? Okay. Next slide. So what's the downside of this? Well, we lose the property that it's an incremental approach for a developer. So if someone's already using peer connection and they want to switch to this alternative path of simple RTP transport, it's hard because it's a different API. It doesn't do as much. It's a more low-level API. It just does packets. So next slide. our idea is to make the transition easier in the spirit of WebRTC samples to write example apps of how to use simple RTC transport, probably in combination with like web codecs, as a replacement for peer connection. Now, not necessarily the same on the wire, not necessarily compatible with non-web endpoints, but if you had a web app where there's two web pages connecting to each other, you could accomplish the same thing, but the example app would implement what's needed to make the transition easier. So instead of the browser, simple transition basically being baked in order to be piecemeal or incremental, instead we'll, in the browser, have a totally alternative path, which is lower level API, and then there'll be example apps to say, okay, you take the example app, you transition to that, and then below the example app in that JavaScript, you can change anything you want. And as one person put it while we were making this presentation, your imagination is the limit. So next slide. We want a future conversation to go like something like this. A web developer will come to us and say, I need peer connection to do this, X. And then we, or whoever's browser vendors here, or the WebRTC working group as a whole, we say, that's easy, just use simple RTC transport. And the web developer says, but it's hard to move from peer connection to that. And we say, well, here's this example app. And they say, oh, great, this does everything I need. And I can do all my niche things, and I don't need you to change the browser. And then the browser vendor or the working group members will quietly say, I'm glad we didn't have to discuss this for 3 years in the working group meeting. So that's the idea. Next slide. We can get into what the network protocol would be. It could be a simplified ICE and SRTP. It could use Quick. It could be something else. But I want to get to the next slide, where the actually, yeah, okay, I'll talk about the API a little bit. I wanted to get to the slide where I ask you a question, but we'll go through this. So look at the bold parts, squint at the rest. Basically, it would look a little bit like peer connection in the sense that you construct something, you get some local parameters that you need to signal over to the other side. The other side gives you its parameters, and then you say, okay, let's do our thing where we connect to each other. But importantly, if you see in the middle of the slide, you are in charge of sending and receiving packets. And this style of reading packets that you can do it in a buffered sense is from RTP transport in the GitHub repository already. But the important thing here is it's just the packet API. You send and receive packets. They're peer-to-peer congestion controlled encrypted packets. Next slide. And then one of the goals of RTP transport being to customize bandwidth estimation or custom pacing. I basically translated the existing example code on the GitHub repository for RTP transport over to this, which is almost exactly the same, except there's nothing RTP specific necessarily under here, because it could be a different network protocol. We don't know. We haven't discussed that yet. Next slide. Okay, so the questions I have for this working group are the following. Number one, should we go down this path, kind of abandon the piecemeal and go with the low-level approach where we provide example apps? Number two, assuming we do, should we do it in this working group? Because maybe someone will say, Peter, you're doing something with Quick. Maybe that should be part of the web transport working group. Or maybe someone says, you should make a completely different working group, or use the WICG or something else. And then if we get down the path where we say, yes, we should do this and it should be in this working group, then we can discuss what that network, or we think that network protocol should be. So this is the feedback I'm looking for. But if you have any questions about the API or the idea, you can ask that first. Feedback, questions. Janivar.
Yes, so if you go back to the slide, please, where it says if peer connection can do X. I think you kind of asked for this feedback. So I think that's the wrong question. I think the right question is, I need to do X.
Sure.
And not necessarily how can peer connection do that. So you mentioned web transport, and I feel web transport already solves this. And the example app is pretty much what Bernard wrote with the web codecs echo server. So the remaining question then is, what is missing there? From
Sure. The two things missing from web transport are peer-to-peer and real-time.
Real-time also.
And customized congestion control, bandwidth estimation. Sorry, 3 things.
Right. Yes. So the concern I have a little bit here is, well, first off, starting from API makes it a little hard because, you know, we could suggest polyfilling all of this on existing APIs. So it's not really highlighting the real problems, which I think you mentioned, our congestion control, like circuit breaker, we've talked about in the past in web transport and not being very happy about. And also, so having something pure bare bones without that goes lower level than web transport, I don't think we would be excited about. But you did mention quick. So
well,
if we're talking
hold
about,
on. I don't think it would need to be lower level than web transport, but it would need to have capacity for peer-to-peer and to turn on a real-time congestion control, and also hopefully be able to have some customization of the bandwidth estimate. So the datagram level of web transport as a baseline is fine. It doesn't need to be lower level than that.
Right.
Except it needs to be peer-to-peer in real time.
Okay. Well, I think if we wanted to talk about something, like if you wanted to negotiate, instead of data channels, you want to negotiate web transport over SDP, for example. That's something we might be able to talk about. But as far as API surface, I think we've already solved some of these problems. Even, you know, we do have some congestion control support in web transport, and also the input-output, the I/O with JavaScript here would solve with streams. So I feel like web developers shouldn't have to learn yet another API just because they wanted to do peer-to-peer. So if we want to go this direction, I think we want to capitalize on what we've already solved to some extent. So, but if we could imagine some kind of WebRTC beast with a web transport head, if you will, not charitable perhaps, but maybe that's something we could look at. But you asked some good questions here, like which working group would even start with that? And I know there've been some effort on quick over WebRTC before. How do we want to pick that up and how to move that forward, I think are good questions. Tim?
Yeah, I'm just going to step back a tiny bit first, which is that there are real use cases. And I think maybe, Peter, it would have been worth kind of reiterating that, that there are use cases of things that you pretty much can't do with WebRTC, although at first glance you'd think you could. And you also can't do them with web transport. I mean, the most recent thing is trying to get data out of a LiDAR and into something that's on a relatively near network, and you don't want to go through a server. There isn't a way to do it. So not in real time. So I think there are real interesting use cases for this, and I think, you know, Peter's requirements are dead right. And I think the other thing that we came out with was that there was no appetite for anybody to implement what we thought was the right WebRTC closely related WebRTC API. I mean, we came out with an API that looked like it was kind of WebRTC friendly, but then when we looked around the room and said, well, okay, who's going to implement it? Everybody ran for the hills. There was absolutely no enthusiasm for implementing it, which is why I think we're where we are. And so I think layering on web transport and WebRTC together with a bit of quick manipulation of stuff is going to, I don't see who's going to implement that. I mean, that's the question you also maybe could have asked at the end, Peter. It's like, who's going to implement this? This has to be something that people will actually roll out into browsers, and I think that's the problem at the moment. So that's my kind of offering.
You summoned Philip. Philip, fill us in on who would be willing to implement what. You're muted. Philip, you're muted.
I guess you already held the presentation.
Oh, yeah, we got to the point where Tim said, who is willing to implement and what are they willing to implement?
I mean, we're willing to implement the API and everything around it, or maybe I'm misunderstanding the question.
Oh, did you miss the last 10 minutes or so?
Yeah, I just.
Oh, okay. All right. The summary is we went down the piecemeal transport path, and then as Tim, I messed up your last name. As Tim said, we ran for the hills when it looked like we needed to implement it, and then another idea was about kind of trying to unify web transport and WebRTC. So Tim was like, "Well, who's going to implement that?" And I was going to reply on your behalf that someone at Google was definitely interested in implementing what I'm calling in this slide simple RTC transport.
Yes, that's correct. We are willing to implement it, of course.
So maybe I can repeat some of my feedback. I don't think we will be implementing something like that because it sounds like it's way too low level. And starting from an API, it's not clear how you would solve the hard problems. So the advantage of Quick is that you already have congestion control, whether you want to call it real time or not. There's a model for improving congestion controllers, and you also get flow control wired up already. So if we look at the technical problems.
Okay. Yanivar, sorry, can I just interrupt you for a sec? I specifically did not want to get too much into the weeds of the API shape or the network protocol before answering the more fundamental questions of, should we back up out of the piecemeal approach and go with something else? That's the first question. And second, if we do, should it be done in this working group or somewhere else? Because after that, we can go and I put as a third question here, the network protocol, but we can also talk about the API, like how low level is it? What is the network protocol? But the first two questions are the most important. So sorry to interrupt you. I just wanted to get those first two talked about before we dive into particular API shapes and network protocols.
Sure. I worry, excuse me. I worry it's a bit of a false question because if we start from the API, it is something that in theory could be polyfilled on top of anything. So I think we have to dive into which technical problems are not solved that we wish to solve. And, one of them is web transport is great, but it's not peer-to-peer. JavaScript APIs, I don't think it's going to work to have send packet and receive packet methods. I think web transport has already solved that with streams, where you can have queues for datagrams and such. Now, ideally, I think we would be 1 year down the road with web transport, where it's widely deployed and we've confirmed all our bets are working before we double down on the concepts. But I also don't see that any other working group has provided anything better. So I think if we look at what we would be willing to implement, I think we'd be more likely to implement negotiating web transport over SDP than don't know, that Quick seems quite compatible with ICE. So that seems like the smallest, most surgical piece of technology that's missing that might be able to give people what they're missing today. And I'm not even sure. And also on the API point, I think the API is a bit of a red herring because web developers who don't need P2P particularly, hopefully can already make do with web transport and get to quite good real-time performance there. And they shouldn't have to learn a different API just in case they wanted to do peer-to-peer. So I think we need to find a way to reuse the investments, the bets we've already made.
Okay, Tim?
So I think to answer your questions, yes, I think it should be pursued. I think there's a need for it. Whether it lives in this working group, I'm not the expert on that, but I think if it's going to be kind of, if the starting point is an ICE transport or one of the other peer connection related objects, then yeah, it makes sense for it to be in this working group. But if it's off on its like doing its own thing, then I don't see any need for it to be in this working group. Like it makes sense if it ties into existing objects that we've already defined and are there. But if we're not reusing those objects, from a technical point of view, I don't see why it would need to be in this working group.
So, oh, sorry. Maybe I need to raise my hand.
No, go ahead.
Oh yeah, no, I just want to say that I think this effort or the thing we're proposing, you could reasonably say that it fits other working groups as well. But I would also say reading the charter and kind of what we aim to deliver, and also the motivating factor or reason behind this API, I think this group is a good fit, and also the fact that even though this is supposed to be kind of a low level peer-to-peer API, it is also kind of RTC focused because we're basically gonna allow low latency kind of congestion control or congestion control, but other forms of congestion control is basically going to be disallowed. So it's like RTC focused in that sense.
Sorry, I unmuted there. So yeah, I think what's missing here is that if we wanted to do Quick over ICE, it sounds like that's something some ITF working group would ideally start with. And then we would add a API. As far as where the API would be worked out, I think in web transport right now, we're getting close to wider view on 1.0. But I could talk to my co-chair there to see if we could take on the peer-to-peer request and to anticipate Quick implementation over ICE. As an avenue. And that seems like the best approach to me.
I should point out that ICE plus Quick together is not really complicated at all. And in fact, I already wrote a draft explaining how that can be done. And the RTP over Quick guys sort of cover that, but not in much detail, last I checked. And that there is interest, or has been, I haven't checked up on the very latest, like from Madrid, wanting to do Quick peer-to-peer without ICE, but it would still be ICE-like. So
without ICE, okay.
I mean, it's possible. You just do ICE-like things, but without the same packet format.
When you say without ICE, you mean with ICE Lite or something else?
No. I'm like, if you distinguish between ICE, the packet format stun packets, and ICE, the idea that you take lots of network routes and you probe each one, just the concept in general. You could do the second part with Quick packets, which I think is what some people in the ITF are wanting to do. But either path is possible. So yes, it's possible to make Quick peer-to-peer in either direction. And it's also possible to make an API. The predecessor of web transport called quick transport was just that.
Right.
So yes, it's possible. But you would still need to solve the real-time part, which, I mean, we can get into the weeds on that, but
Well,
if we did peer-to-peer real-time quick, there's like an overlap between, is that a web transport thing or is that a WebRTC thing?
but I don't understand why we would solve real-time congestion only for peer-to-peer. It doesn't seem necessary.
Well, anytime you do anything peer-to-peer, you're also doing it client to server.
Right.
Just like
So I'm
people right
saying,
now
you
run
know,
a server with RTP.
so Bernard's web codecs demo is sort of the best we have, and it's working. And so I would say that people who say that's not real time, I would guess we could make it better. But it seems pretty good.
I have not yet seen an implementation of Quick that has a real-time congestion control system on par with what we do with peer connection today.
Yes, but I'm making the point that if we want to improve that, we should make sure that we improve that both for client server and web transport users. I don't see a reason why we wouldn't solve that in web transport as well.
We
got a
could.
bit.
That is,
so I'm trying to avoid artificial silos here.
That is an option.
I think, I mean, of course, we want to maybe bring as much value as possible, but it could also complicate things quite a bit. Like, you know, true real-time communication is different from just data flow. Even though I know that Quick, you know, even though there are no hard limits on what type of congestion control you should use for Quick, and I know there's been a lot of efforts with BBR and everything to kind of keep the delay low. Still, like, doing real-time congestion control is quite different. And of course, I'm not saying this just to, as I said, like, of course, we can try to bring as much value as possible, but it could also complicate things quite a bit.
Right. Just speaking to, I think what we would implement, I think where there's some difference about how much, I'm sensing a bit of difference of how much browsers should be involved with congestion control versus applications. And so that's an area where we're very interested. And so I think we might be up for the task, but I think we want to make sure we use existing building blocks. And that's an approach. We prefer that better than burning it all down, if that makes sense.
All right, but if you want to make something that looks just like web transport, but is also peer-to-peer in real time, do you want to do that in the web transport working group, this working group, or something else?
I think in either of those two working groups. And I think where to start, well, I think it'd be good to have an ITF spec to lean on. You said you've done some work there. Is that something we could do through AVT Core or something like that?
I mean, yes, that's, I think I wrote it for that group.
Or the ITF Web Trans working group.
Yeah, it could be there too.
And would you be, because it's taking the API approach of something simpler. I know that we all love SDP, sarcasm, but looking for a simpler API could also be done by polyfill on top of SDP. Like, you don't necessarily have to resolve all the problems. So if there's a way to negotiate, I mean, we could polyfill this on data channels, and as a hypothetical, what's wrong with it? You'd mentioned congestion control probably, and the lack of streaming, and probably also the lack of back pressure. And those are your three problems that we would try to solve by, instead of negotiating data channels, to negotiate web transport.
I mean, we could try something where we beat the square into a round hole, but yes, you could theoretically have a new SDP line that's like new thing here, and then you get a data channel that's not actually SCTP underneath, but is a new thing. But the API looks the same, where you call send and have an event. I do think that there are some downsides to that. In particular,
Oh no, sorry, I didn't mean the send API would be the same, but you basically get something that looked like web transport, where you can create unidirectional, bidirectional streams and send datagrams out of that negotiation. So you get a WebRTC engine with a web transport head.
So that path is the one that ended up at the predecessor of web transport, which was quick transport, because we didn't need STP to do ICE, so we just made an ICE transport to go along with it. But if you really wanted to keep STP, yes, that is possible, and that would avoid most of the issues with peer connection, as long as you didn't mix, like one.
Well, I'm trying to take on the problems one at a time rather than as a big. I mean, if we want to get rid of STP, that's potentially a large task by itself.
Well,
So,
No, only if you're trying to replace peer connection. If you're trying to do like web transport doesn't use STP, right? That would be ridiculous. So if you're
well,
making,
it doesn't do ICE.
yeah, but making an ICE transport and combining the two, that's already been done. Like,
Okay,
we have proof of possibility by the fact that it already existed once.
right. But I guess also having confidence that we can get somewhere that is beneficial in the end. As I said in the beginning, I worry that web developers shouldn't have to learn yet another API. We already have a kind of disparity between WebRTC and web transport here, and making a third thing might seem tempting because we don't like details about the other things. But
that's why I was bringing up. That's why I was bringing up the web samples, is like the WebRTC samples. Because we can provide them as a sample app that polyfills something that looks like what they already have on top of the low-level thing.
Yes, I'm worried that by combining API and talking about all the things at once, we're not going to make progress on any of them.
I think, I mean, at least the way I see it is that this API is so low level that it actually makes implementation and everything just so much simpler. Because we don't have to think about the domain, we don't have to think about how people build their apps and blah blah blah. It's just you send datagrams. So in terms of solving a bunch of hard problems, I'm not saying we have a clear solution to every problem in regards to what we're proposing, but I think overall, at least my view of what we're proposing, one benefit is that it is very simple, and also to explain it to anyone who want to use it, it's very simple. Yeah, that's kind of my take on the whole API complexity thing.
Well, I would question that it's all very simple. I think I don't want to be here forever, and it sounds like we've spent a long time getting to where we are today, and there are a lot of details once we get into them, and so I want to make sure that this. I'm also not sure this is exactly what. There's also if we build it, they will come thing here where we assume that there are enough developers that want this level of complexity that's bare bones, and I'm not seeing evidence of that. Tim?
Yeah, so two things. One of which is I think we shouldn't regard like developers having to not learn, having to unlearn peer connection as a bad thing. Like, I don't know anybody who loves peer connection. I don't know anybody who wouldn't like, and it's not simple, and it's not going to get any simpler, right? It's not. So I don't think we should be like holding it up as a gold standard in any way, shape, or form in terms of developer experience. It gets stuff done, and I'm not knocking it, but I'm also not saying it's a thing that we need to hold on to desperately. So that's like that thing. And then I do think that it would be quite easy, I think, to find a bunch of people who wanted to use this API. There's been quite a lot of interest in the RTP transport group. People have come in and said what they want to do, and not all of their user requirements are like exactly the same, but I think almost all of them would be met by this super low level API. And I suspect that if one span it up, you'd get a lot of people in a field trial. You get a lot of people using it. I mean, I can see a use that we'd have for it. Like I said, with the LiDAR stuff, which data channels simply cannot do. I've tested that and it just doesn't work. With over SCTP, it just doesn't work. And I suspect that Quick may have some related problems, but I haven't tried that yet. So, and there are people in the games world and other places who've expressed a lot of interest in this. And so I think I'm on the side that if you build it, they will come. And I think that is very likely, actually, based on the feedback that we've got. But obviously, I have no proof of that.
All right, so far I've heard either this working group or either. I've not heard anyone say don't do this, and I've not heard anyone say go elsewhere. Are there any other voices that want to pipe in? We've mostly heard from Janivar, Philip, and Tim.
I just wanted to, I guess, clarify one thing I said. When I say it's simple, it's nothing in terms of introducing a new transport API. It's certainly not simple. It's certainly not trivial. I guess I'm just comparing it to kind of peer connection and APIs that gives us similar capabilities. Well, it doesn't, but real-time capabilities and peer-to-peer and all of that. But I think when I think about this API, it's like if you were to take peer connection, you remove 98% of all functionality. Then you basically get this new RTC or simple RTC transport. The only thing that is unsolved is, or like that is an open problem that needs to be looked into or figured out, is kind of this app level pacing or app level bandwidth estimation. That you're allowed to send packets at a certain time from the application. That's the only thing we have to kind of figure out, how to implement a circuit breaker that is effective to not allow people to abuse it. But that's kind of the only technical thing that we're kind of proposing that is not already being done. Everything else is already being done.
So I would just, Peter, since you asked, has anyone opposed to this? And if by this you mean simple RTC transport, I would say no, I would not be supportive of that. What I would be supportive of is looking at ways to get quick over ice, for example, and make progress on the problems individually, because frankly, what we're looking at here, there's not enough detail to say, this could be RTP transport 2 years ago. And then I actually have some questions of why didn't that work out? You said implementation turned out to be hard. How do we know that this isn't going to happen again?
Okay. Harold.
So the two unsolved issues, when you want an encrypted transport and you want the congestion control transport, or at least a circuit breaker transport, or you got to have the key negotiation part settled, and you got to have the feedback format settled, the part that passes across the wire to tell the browser what's happening with the congestion. And those are not trivial problems. So I'm personally hesitant to say yes or no to this idea without a clear idea that we have solutions to those two that will fit within the concept. By the way, IETF, after the experience with simple network management and simple mail transport, IETF banned the word simple as a name of a protocol.
All right. I'll call it complex RTC transport. So about the feedback. So if we went with quick, then we would need probably the receive timestamp extension. And if we went with RTP, we would probably need to pick, I think it's 8888 RFC, the IETF version of Transport CC. And for key negotiation, we would either have to pick DTLS or some other Diffie-Hellman exchange. Or if we picked quick, it would just be kind of solved, assuming we could have mutual certificate verification. So yes, we do need solutions for both of those.
Yeah, we can talk more about the details later, but I think there are clear solutions, but maybe I'm naive. I don't know. We can talk more about it later.
So I just wanted to point out Harold is right that like we do need to solve those things.
Yeah,
and there are some.
I mean, we need to solve it, but we already know that defining some form of feedback data to figure out what's going on is already possible. It's not like, is this technically possible? Then I would say yes, it is. Do we need to solve that problem? Absolutely. But is this like an unsolved problem where we know that this may or may not be technically possible? Then I would say certainly technically possible.
Right. It's more like taking solutions that are already out there and putting them together. Yeah. It's not new rocket science.
Yeah, exactly. Yeah.
So I just want to say that if we look at video conferencing, for example, it's when we say peer connection is complicated, most video conferencing isn't really peer-to-peer anymore. So a lot of the complexity came from starting from peer-to-peer as a starting point. So complexity is relative depending on what you're trying to do and where you're coming from, and whether the tools fit. So I would like to offer to talk to my co-chair for web transport, because I think the problems we're solving here with real-time congestion is interesting to web transport as well. I don't think that there's anything unique about peer-to-peer that means we should only solve real-time congestion in those situations. So, we're trying to get web transport to 1.0. So maybe that's something we could do, maybe split out another deliverable document or something like that to work on this, if that would work.
If somebody solves the make quick real-time congestion control, that would be great for lots of things, not just this. And if somebody has a good solution for making quick peer-to-peer, that'd also be great. And yes, those are orthogonal things. They don't overlap.
Great.
Okay. Well, I think I got enough feedback, so I can hand the time back.
So is there any resolution to document then? Or? I guess follow-up conversation is happening in web transport for now.
Well, I'm happy to take an action to investigate with my co-chair there, if there's something we can take on here. And I definitely, as far as Peter, you mentioned some ITF specs that I might be interested in. The part that's tricky for me is if we just assume that we have quick over ICE, that might be a bit unstable to build on. If we can get anything on the ITF side to back that up.
Sorry, what's difficult or unstable?
Quick over ICE. I know you've written some things there.
That's more like quick next ICE, but
okay.
If you want me to get the link to my draft, it's probably expired, but
okay, great. No, I'm more on the API side, so anything on the ITF side there that we could build on would be great.
I found it. I'll send you a link right now.
All right, thanks. So Dom, to your question, is that more for this working group to do here? It's unclear to me a little bit, but I guess starting in web transport might be. Well, I'll see what my co-chair thinks.
Peter, are you putting the link on the chat then? Or? Oh,
I
thank
just did.
Thank you very much.
Thanks. All right. Any more on this topic? Otherwise, we're 5 minutes early. We can go to the next topic. So this is fairly lightweight, I hope. Firefox has been implementing transfer of data channels to workers. So a couple of issues came up, and we wanted to just get some feedback from other implementers and the working group about some of the questions we had. So we had 3 issues filed. Data channels and workers get initialized on the wrong thread. And also they get garbage collect. We recently added code to the working group recently added that we don't want data channels to be garbage collected too soon, but that doesn't work in workers. And we also had some concerns over losing data channel events during transfer. The next slide. So if we look at the spec algorithms, I tried to summarize it here. But basically, when SHTP connects, it queues a main thread task to fire the state change event on the pc.shtp on the SHTP transport object, and it queues. So basically, sorry, it queues a task on main thread to fire state change with all data channel IDs initialized, and I do mean all because it does basically says something like for each data channel object that this connection owns, basically, which is not the same as there's an internal slot called peer connection data channels, which tracks the ones on main thread, but in this case, it's really all. Or is it? So turns out different implementations have implemented this differently. So here's some code where I create a data channel, and I immediately, when you create a data channel, you have a very short window of when you can post message it to a worker, which is pretty much within the same task, effectively. Not entirely, but close enough. So you have to post message it immediately if you want to. And then the code calls set local description, which is what you need to do in order to get the SHTP object. And there's an on state change that you can register here to get the state change event when it turns connected. And when it connects, and then I put the rest of the negotiation logic into a subfunction. We don't care about it, but assume that connection then negotiation completes here. The state will change, the SHTP state will change to connected. And if at that point you try to look at any of the data channels IDs, you'll see that they're initialized in Chrome, but they're null in Safari. And over on the worker side, the worker wakes up, gets a message, and again, you interrogate the channel ID that you just got from main thread. And the worker copy, the worker transferred object is also initialized in Chrome, but null in Safari. And I don't actually know how it got there in Chrome. So that's the first question. And also, but for both implementations, when that channel gets an open event, at that point, the channel ID is initialized. So this difference in behavior, we need to pick one, and the proposal here is to align with Safari, because even though Chrome perhaps follows the spec literally here, I'm a bit worried that it's initializing IDs on the wrong thread. So it might be cleaner to move data channel ID initialization into the open, which is a separate task. Tim?
Yeah, clarification here. Is that the only property that's mishandled? or is it does it apply for the other ones like label?
I believe it's only this one because the channel ID has special logic in the spec for not knowing that number. There, you can do negotiated true, in which case it's the JavaScript that provides it. But if you don't do that, then so there's some. Actually, I have another slide on that, so maybe I should go through that as well. But I think it's only unique to the ID.
Okay, thanks.
Next slide. Maybe I can go into a little more detail. But yeah, the proposal here is to align with Safari, so I can take questions on that at the end if you want. Oh, sorry, that was the only slide. You can go back. Thank you. So yes, any other questions on this? Any objections to aligning with Safari here? I should explain that there is a data channels. Okay. That's an internal slot basically.
No, I had the wrong. I wanted to raise my hand. Not,
Okay.
Yeah, no,
Oh.
Yeah, you mentioned that that the Chrome is implementing the spec literally as it's written, but that we should change the spec to align with Safari. So I would like to, before I'm not saying that your idea is wrong, but I would like to take a look at why Chrome is doing it that way
Sure.
before agreeing to this. So I need to look at the implementation details to know exactly why it's that way, and if changing that would cause any problems. So let's yeah, continue the discussion.
No, that's great. I can try to explain a little more here, which is that part of the issue here is that when SFTP connects, it queues a task on the main thread to find the state change event, and it does a lot of initialization of all data channels on that thread, which if you're actually touching worker threads might be an issue. So I would look at that. But when we thought about how to solve it, we could there's another event coming right after, which is a separate queue task, which is in the sub algorithm of announced data channel is open. And that queues a separate task. So one idea we had was to push the initialization of the ID of all IDs down into that one, but that might be a breaking change. So I think what we probably want to do instead, the alternative would be to initialize the main thread data channels like is done today. But for workers, data channels and workers, we probably would also initialize them in the announce the data channel is open, which is the last line on the slide here. So that you would have the slightly different behavior in worker where channels in workers would have its ID initialized a bit later. Out of necessity, because it's in a whole different thread. But yes, happy to discuss on the issue.
So Janiva, your expectation is that changing it on in workers wouldn't be a breaking change?
Yes, yes. I also don't know how to specify the current Chrome behavior there. Like where did it come from? The ID.
Yeah,
happy to investigate with Peter.
Yeah, let's do that.
Okay. Thanks. Next slide. So another issue was that we a while back added an internal slot on a peer connection to hold a strong reference to all data channels, basically all main thread data channels, because we did that just before we exposed it to workers as well. And that's basically the proposal here, without going into too many details, extend this to workers somehow. So, and I just like shedded some language here, ways we could do that. It's basically, what does it say? After transfer, use agents must keep a strong reference from the window or worker global scope object that the data channel object constructor was invoked from to the data channel object for as long as the original detached object that was the source of its transfer is kept alive, or something like that. Basically a way for the main thread connection data channels internal slot to keep data channels alive no matter where they are, which I'm hoping already exists in implementations. We need to fix up some of the spec language around there as well. That subtle detail here is that when you transfer an object like a data channel from main thread to worker, it's actually like the magic trick where they without spoiling a good movie. There's a magic trick where a bird is in one hand and under a hat disappears and appears somewhere else, and you learn later that the bird wasn't actually transferred. The old bird died basically, and there's a new bird. So just to say that when you transfer an object from main thread, the existing object on main thread is still there. It's detached and closed in the case of a data channel. So the internal slot holds basically a detached object that is the original to the one that's in the worker. The one in the worker is actually a clone with most of its data, internal insights moved over. This is probably more detailed than you wanted, so I think, are there any objections to this? All right, I'm not hearing any objections. Okay, so we can move to the next slide. And we filed an issue because there was some concern about data channel events during transfer. So since I put in a placeholder slide on Friday, I tried to investigate whether this is actually an issue. I found some pros that suggest this is already taken care of in the spec. I just wanted to highlight it in case implementations aren't aware of it. There's some language when you create a data channel algorithm that ends with queue a task with the following step that sets transferable to false. And then it says this task needs to run before any task in queue by the receiving messages on a data channel algorithm for this channel. This ensures that no message is lost during the transfer of a data channel. So just pointing that out, that there might be an interest to double check your implementations. We don't have any signs that there's anything wrong, but it does. We did find that, you know, if you create a negotiated true data channel, then it's basically up to JavaScript to make up these IDs. And there's a note in the spec already that if it negotiated is set to true, the application would also take care to not send messages until the other peer has created a data channel to receive it. Because if that were to happen, that it would be undefined behavior and might be silently dropped. So there does seem to be some inherent races here that an implementation would hopefully take care of, but we haven't found a spec issue. So just a PSA. Any questions or concerns around this? In that case, I think we can go to the next topic.
So the resolution here is that we make no spec change?
I think so, unless we wanted a note about it. But I think it looks good.
So the issue can be closed, right?
Yes. Yeah. It was thanks to Ewan who pointed this out, that the what saves us here is that there's a very narrow window in which data channels can be transferred. That avoids a lot of complexity, or limited to this sentence. And if someone wanted to write code to basically delay reception of messages here, it doesn't seem too bad. There's only so many data channels you can create before you run out of numbers. So. All right, thank you. Next slide. Next slide, grab bag. So we are a bit ahead of time. So we might hopefully end some early today. So grab bag for discussion. I just picked some issues that seemed like they could be made progress on. First one is we got an ICE error event done recent and RTC error constructor and a question about provisional stats. So first issue here is the RTC peer connection ICE error event should not expose done reason to JavaScript. There's been some tightening around exposure around stun that seemed like, and this seemed like this issue was filed a bit back by FIPO, and it seems like a good idea to me. So the proposal is to either change error text to anything but the stun reason, or remove the error text entirely, perhaps. Any preference? Harold?
My preference is to keep it and just say that it does not reflect the error text from the stun attributes. Reason being that there are multiple reasons why things fail, and having error text to help debug them is usually highly useful.
Great, thanks. That sounds good to me as well. If there are no other comments, we can move on.
So sorry, the resolution then was not quite either of the proposal, right? But change error text
to anything but stun reason. Yeah.
Well, not exactly, right?
Well,
so
remove
it's
the stun reason.
change error text to help with message to help debugging or something.
Must not include stun reason or something like that.
Okay, well, I'll keep a high-level resolution. I guess I will be backshading in the PR.
Great, thank you. Next slide. I also noticed that for the RTC error constructor, this was doing some cleanup. So hopefully not a big deal, but for a lot of our objects, like ICE candidate and events, we followed the event constructor copy pattern, which is basically to take in init dictionary that has a lot of the same attributes as the interface we're creating. A nice side effect of that, which works for any event in the platform, and also for ICE candidate and RTC session description, is that you can actually make a copy that way by passing in an existing description or ICE candidate or event. Doesn't really, it almost works for RTC error as well, except you get this weird behavior where in the copy, instead of null, you get 0 because the dictionary didn't accept null as input, and it gets coerced into 0. And easily fixed with some JavaScript, with some WebIDL, sorry. And as far as backwards compatibility, it seems minor. And we're basically accepting a null, and we stop coercing it to 0. Any concerns, objections, questions? All right, I'm not hearing anything, so I think that means there's no objections. All right, thank you. And the last issue here was filed by Henrik a while back in March, basically asking if we can remove the WebRTC provisional stats spec. And I was supportive of that, so I thought I would bring it in front of the working group. I can read it here. We have moved metrics to from the professional spec in order to make WebRTC stats match what is implemented. It occurred to me that the professional spec contains a lot of metrics that has never been implemented, and I don't think people are referring to it anymore. If we go over all the metrics, maybe we can get into a state where we actually delete WebRTC professional stats stock, but there may exist metrics that have been implemented and shipped still in there. Like content type, can we move it to WebRTC stats without a warning on status on that? Which I would be supportive of. And as a call up to Harald, do you have any thoughts on this one? Harald, if you're speaking, you're muted.
I was thinking of so do we have a list of the stuff that is listed there that is not present in the and the implementation status of them?
Well, there's a link here. There's quite a number of stats, but I don't have implementation information, unfortunately. I know that Firefox has not implemented any of them.
Yeah, the reason why we had this was to have somewhere to keep the stats that would prevent WebRTC stats from moving somewhere, and like PR or something. I don't know how relevant that is.
Yeah, so I guess there are 2 or 3 questions hidden behind this. The first one is, where are we in getting double implementation experience on the regular WebRTC stats? We had started that analysis a while ago, but I don't know that we have taken a more recent look at this. And so, like, if we have enough implementation experience, we could indeed try and wrap it up to rec. For things that have one implementation that are in provisional, we could import them back into main and marking them as feature at risk, and then we would incorporate them through the amendment process over time. My understanding, and I could be wrong, but my understanding was provisional also kind of serves as a registry of good ideas we might revisit sometime. I don't know if that's still useful or not, but that is my recollection of why the document was started in the first place. If it's no longer useful, then I personally agree that removing that extra document and clarifying the state of what's actually being implemented would be a more readable approach.
Thanks, Varun.
So yeah, I just wanted to reiterate, it's okay to delete the provisional stats, but like I think we should reassess why we built it. The idea was that people have good ideas and they may experiment with it in their own browsers. But at some point, if those things don't pan out, we should delete the ones that don't pan out. But if things don't get implemented because of other reasons like privacy or CPU or something similar, then leaving them documented with the caveats would be a good idea, because these problems don't go away and they reappear. People run into the same issues in the future, and they will try to redefine a metric which has been experimented with before. So standing on top of, like, not starting from zero, but starting from somewhere where, you know, you have a good sense of like, oh, someone tried to do this, they implemented it in a certain way, it's defined. Let's start from there as opposed to like starting from all over again. And if people have objections to certain metrics, that's also well documented. Otherwise, we will just go around in circles. And this has happened several times, even on the main spec, where people say, "Oh, I want to have like a jitter buffer or something, and I want to implement this. Why don't we have it?" So kind of comes down to the utility of the document. If it has anything of importance to say, then we should figure out how do we document that. If none of the metrics are interesting, then maybe it makes sense. Like, we shouldn't hold on to a document if it has nothing to say.
Thanks, Dom.
Yeah, so maybe to keep track of ideas that have been investigated, but and for which good research has been done, but aren't ready for implementation for a reason or another. Maybe we could simply document them as markdown file into a subfolder of the main WebRTC stats repo, so that there is a unique place to find them, but they're not in a spec-like format that gives them more, I guess, credibility or more formalism than they really got. And that would let us revisit them if and when new information comes up.
Yeah, I think that's a good idea. And also, the proposal here was to actually identify things that were implemented and try to keep those. So there's some triage work that someone would have to sign up for here to commit. But also, yeah, my concern with provisional stats is as a receptacle for new proposals, because we did have recently we added the stat which for PSNR, and I think while that approach wasn't ideal, it took a long time. I do want to. It does show how I would like people to propose stats, which is to propose it as any other feature, any other API feature. For proposal for standardization, so that this doesn't appear as an alternative receptacle for creating stats without standardization.
Actually, I'm just looking at the provisional stats. There are lots of stats which are well documented, even implemented inside the stack of the RTP and XR blocks, and so on and so forth. They've just not been wired up into get stats, which.
Okay, but when you say implemented, there's a different definition of implemented if it's not shipped.
It's implemented. I mean, stats are things that like get stats is just one receptacle of like a stat being implemented inside the stack, right? Like congestion control algorithms or can use stats that help them. And at some point you may want to expose them to get stats. So, or like in these cases, the XR blocks, they're actually sent or maybe sent between endpoints if they're negotiated. They may not just be implemented and get stats.
Yes, but for the purposes of this working group, which is to expose it, get to browsers, or to web pages, gets that it's the only.
Yeah, so I guess the question is, like, if these things are of value and they're well documented, like, where do we document them?
Yeah, so I guess that's where my proposal would come in. We take the existing description that has all the useful references, and we put them into, say, a proposals folder under WebRTC stats. That way, the day there is enough momentum to pick one of them or several of them, we can restart from this existing research rather than having it lost, but not in a separate document repo that nobody looks over. I think it would be a clearer status that way. Think of it as a collection of mini stats explainers, I guess you could see it that way too.
So what is the action item here? Do we have, well, does anyone object, I guess, to triaging out and try to get this document deleted.
So I think the real question is who would be doing it, or who would do the
Well,
triage?
That was my next question, but yes, I first want to ask if anyone objected to that approach. Harald?
And I would object.
Okay.
And I believe that I don't believe that having a goal of deleting the document is appropriate, given that we don't have a good process for proposing, evaluating, and implementing stats that come up over time.
When you say we don't have a good system, how isn't it just filing a GitHub issue and without a PR?
We seem to have wanted to have a barrier against adding stats to the WebRTC stats before they have passed some limit of a notcher implementation or proof of value or whatever. So I don't think that it's. I don't think the goal of deleting this document is appropriate. My fear is that if someone actually takes on the job of triaging this, we will see some random set of things move to the stats document, and at some random point we'll have a decision to delete the document, and there will be information lost that shouldn't have been. So all in favor of triage, but I don't think deleting it is appropriate. Okay, more people.
My concern with Markdown is I think we then just are saying that we don't like this format of the docs, and we're going to go into a Markdown kind of doc which has the same information documented in a different way, impeding discovery in some sense. This document already has all the monikers of draft. I may be reading the wrong one, but what does the published version say? It just says draft, unofficial draft. It's put the stats in an order that can easily be moved from one place to the other. It's well documented. It follows the guidelines that we have in the main spec. So we don't have to do more work if something does move. It's a standardized format that anyone who wants to review it as a reviewer understands. It's in a dictionary, it extends the dictionary. All this information is already here. So unless we have concerns, I think it all comes down to process, because I think Yanni, where you said hey, we had recently a stat which had a lot of discussion, and maybe ideally it should have start with the provisional stats to begin with, and then migrated from there to the main spec. And that didn't happen because there was implementation already in place with a CR on one of the browsers. So maybe we need to clarify what all of this means. But moving an HTML document which already has it's a draft, it's unofficial, into a Markdown just feels like we lose all the specificity of a spec. It's a downgrade. And we'd have to do the work. Someone would have to go take all of this, put it into Markdown. And the only thing we would gain is that people who don't care will not move their stats to something. That just means that they have to be engaged with the community all the time to have their voice heard. And a lot of these stats were probably proposed by me when I still had a company which does this. And I think they're still valuable. I just don't have the time to actually do the implementation work, right? So But I think if someone else finds value in these metrics, which we certainly have a lot of questions in GitHub, where like so many issues about solving problems for the community. We just don't have stats for so many things.
Thanks, Guido.
I just wanted to say that maybe we should bring this up again when Henrik comes back. We should be next meeting. Ask him exactly what if he has like more concrete proposals about this document. He's the one who made the proposal.
Oh, that makes sense. I would support that. Yeah, from my point, it was just more to get clarity of, like, I'm not promising to follow WebRTC provisional stats for new ideas. So I hope it's clear that to get things in front of the working group, hopefully people will provide issues, which they did with PSNR. Harald?
Yeah, just the main problem with the document is really that there hasn't been a resolved issue on it for 2 years. So it seems that nobody's actually updating the document or looking at the issues.
All right, but yeah, I didn't hear any objection to wait for Henrik to champion this since he filed it. Yeah.
Me neither. No.
All right, cool. With that, I think we're at the end of today's agenda, and we are done way early, which is good. So might be able to give you a half an hour back of your day. Thanks, everyone, and have a good summer, and hope to see you again in September, some date that we will announce on the mailing list. Thanks, everyone.
See you later.
Okay.